students, I hope you are getting my lectures. Dear students, in my last lectures I taught you about trivalent and pentavalent impurities which we can add in a semiconductor to increase its conductivity, and we call this process doping. Okay, so doping is a process of adding impurities to pure semiconductor just to increase its conductivity. Dear students, we have studied so many points, so many important points in pentavalent and trivalent impurities. Whenever you are adding a trivalent impurity in any of semiconductor, then you will get p-type semiconductor. Okay, and whenever you are adding pentavalent impurity, then you will get n-type semiconductor. Dear students, in p-type semiconductor, there is forming one acceptor energy level and it always lies above the valence band. Okay, and on the other hand, in pentavalent impurities there is formation of donor energy level which lies just below the conduction band. So these are some important points which are asked in exam, and they may ask that which are the elements which we can add as trivalent impurities. So these are the elements like aluminium, gallium, indium and thorium. Okay, so dear students, you can keep in mind like aloo, gajar in thali. So these all we have studied, and we have studied the difference between intrinsic and extrinsic semiconductor. Now let us start our next topic, that is electrical resistivity of semiconductor. This question can be asked in exam, that find an expression for electrical resistivity of semiconductor. So diagram is same. We have taken one semiconductor, okay, in which electron and hole, everything is there. We have connected it with the electric field. Electric field is from positive to negative. Obviously the electron will shift, they will drift in the opposite direction and holes will drift in opposite direction, because electrons are attracted towards positive charge and holes will be attracted towards the negative charge. Okay students, now everything we have written here, that consider a block of semiconductor, length is L, area of cross section is A, and E is the number of electrons and H is the number of holes, and we know that what is the relation between current and drift velocity. In unit 2 we have studied, it is I is equal to NEA VD. So if we will take for electrons, it will be IE is equal to NEA VD. VE means electron velocity, and IH will be equal to NHEA VH means velocity of hole. Then what will be total current? Total current will be I is equal to IE plus IH. Just take addition of both, and you know that EA is common, so it will come outside. Students, now we will apply here Ohm's law. V is equal to IR. V is equal to IR, Ohm's law will apply. So put the value of I and R. A and A will cancel out. A and A will cancel out. Then you will left with last expression, that is V is equal to NEVE plus NHVH rho LE. So three terms left with you, rho LE. Now we know that what is electric field? Electric field is potential per unit length. So put the value of potential here, cancel the terms, L and L will cancel out, you will be left with rho. Now rho we can take on the other side, students. Take rho on the other side, then it will be your E upon rho, NEVE NHVHE. Now E we will bring on the other side, it will come in denominator and you will get this expression. Now E we are taking inside. Dear students, velocity per unit electric field, the velocity gained by the particles per unit electric field is called as your mobility, and mobility we are denoting by the letter mu. So this is your 1 upon rho means reciprocal of resistivity. Rho is resistivity. You can do it up to here also, but if you want to do it further, then reciprocal of resistivity is conductivity, and conductivity we denote it by the letter rho. Okay, so you will get NE mu E plus NH mu H whole multiplied by the E. Dear students, this is the expression for conductivity and resistivity of semiconductors. With this topic, we have finished our chapter number 1 of unit 9, that is solids, and tomorrow means next day we will start our next chapter, that is semiconductor devices. Okay, but before that you should clear with the terms like p-type semiconductor, n-type semiconductor, and what are the small things which are related to these topics. Okay, because there's so many questions are coming for 1 mark from these topics. Like they can ask you, where does the donor energy level in semiconductor lies? So you can tell that it lies just below the conduction band. Where does acceptor energy level lies? So acceptor energy level lies just above the valence band. Okay, which type of semiconductor you will get when this pure semiconductor is added with impurity like gallium? Then your answer will be p-type semiconductor. Okay, if it is added with let us suppose any other element, okay, which will give you n-type, so you will write n-type. But maximum which are coming in exam for p-type are aluminium, gallium, thorium and indium. So accept these 4 if anything is coming, that is your n-type semiconductor. Okay, which are the majority particles in p-type semiconductor? Holes. Which are the minority particles in p-type semiconductor? Electrons. Which are the majority particles in n-type semiconductor? Electrons. Which are the minority particles in n-type semiconductor? Holes. So these are the small questions which you should know about this chapter. So this is enough for today. I hope you got my lecture. For any queries you can leave comment or you can leave message in my WhatsApp. So this is enough. Thank you. Have a good day.